Hey everyone, and welcome to today's Explainer. So, today we're tackling the massive, totally unavoidable shift brought on by AI. But, to truly understand how to handle the technology of tomorrow, we actually need to, jump into a time machine. Seriously, we are heading right back to the 1990s to solve a very modern mystery about innovation, planning, and what happens when we just let technology take the wheel without a map. Okay, let's dive into this, because it seems like a massive paradox, right? I mean, comparing clunky early 90s computer networks to today's mind-blowing AI platforms, it sounds crazy. But the reason we're doing this is because human behavior, it literally hasn't changed. The tools evolve at absolute lightning speed, but how we actually implement them still falls into two very distinct buckets: rigorous, careful planning or chaotic improvisation. Let me tell you a story. Back in the 1990s, San Pio Hospital launched this major tech initiative. Now, phase one was a voice reporting system for radiology. They partnered with IBM, they mapped out literally every single detail meticulously, and it was a huge, resounding success, a total home run. But then came phase two. This was a downsizing project for the labs. And instead of that rigorous planning, the task was just handed off to a group of new graduates who completely, totally improvised. They skipped the most elementary design fundamentals, and the result? Oh, it was an absolute nightmare, a complete disaster that required agonizing, constant maintenance. Because, you see, it wasn't a technology failure at all. It was a process failure. Let's move to and see how this builds. Because if you trace the evolution of computing, this pattern of abstraction becomes super obvious. Back in the 1980s, right? Coding a game meant working in raw assembler language. You were physically manipulating memory registers. By the 90s, high-level languages kind of abstracted that hardware away. And today, with modern AI, the abstraction is just astronomical. And this is absolutely crucial. Even though we are further away from the bare metal hardware than ever before, the absolute need for strict design principles hasn't changed one bit. Improvising with AI today sets us up for the exact same disaster as that 90s hospital project. Which brings us right to the core of today's tech boom: large language models, or LLMs. We so often see these treated like, magic boxes, right? But at their core, an LLM is essentially just an unstructured macro language. It's incredibly powerful, for sure, but it relies entirely on precise human instruction. If you're just throwing vague prompts at an LLM without any real framework, you're just doing modern improvisation, and we already know how that ends. So how do we actually avoid that disaster? Well, just like a strict business model or, say, a rigorous architectural plan, effectively using an LLM requires 4 foundational steps. First, you got to define the context. Second, set clear objectives. Third, identify your constraints. And fourth, allocate your resources. You absolutely cannot skip these. An AI project doesn't just magically generate its own purpose, It needs a human to build that specific framework. Without defining those boundaries, the AI simply cannot give us reliable, sustainable results. It's that simple. Now, what's really interesting about this slide is that we aren't taking this from just anyone. Federico Faggin, the actual inventor of the Z80 microprocessor we mentioned a minute ago, warns us explicitly about this. He says, do not overestimate AI. He points out that it's completely, utterly incomparable to human intelligence. And honestly, I think that helps scale down that existential fear we all have that AI is just going to replace us all. It's a fundamentally different mechanism entirely. Actually, try thinking of AI as the modern wheel. When the wheel was invented, it totally revolutionized society, right? It drastically reduced human physical fatigue, but, and here's the kicker, it didn't replace the need for someone to actually steer the cart. AI is exactly the same. It's just applied to cognitive labor instead of physical labor. It is a support tool designed to make massive, overwhelming data processing manageable, but it still absolutely needs a human driver to give it direction and purpose. To see exactly why we need this cognitive wheel, let's pivot to a specific real-world example in healthcare. 20,000. Take a second to think about that number. 20,000. That is the number of scientific medical publications released every single year. The sheer volume of new information being generated out there has massively, incredibly outpaced the biological processing capacity of the human mind. We are, quite literally, drowning in global knowledge. And this brilliantly illustrates the problem. Out of those 20,000 scientific publications, a typical doctor might realistically process maybe 2,000? That leaves 18,000 publications entirely unread by that practitioner. Now, what if a life-saving solution for a patient right there in the ER is buried somewhere in that 90%? This right here is exactly why AI is a vital, totally non-negotiable support tool. It can instantly scan those 18,000 unread documents and highlight the exact specific information the doctor needs to literally save a life. So this integration, this merging of human wisdom with raw artificial processing power, is the cornerstone of what's being called Revolution 5.0, or Transition 5.0. It's a major shift away from being purely technocentric toward being definitively human-centric. But to make this transition safely, to ensure the AI actually serves humanity rather than just creating a bunch of unintended chaos, we have to intentionally program it using one ultimate, indispensable soft skill. And that skill, believe it or not, is empathy. Now, in the context of high-level technology, we aren't just talking about a vague, warm and fuzzy feeling. No, empathy here is a systemic framework. It is the measurable capacity to understand and align with the physical and psychological well-being of the entire ecosystem we're interacting with. Empathy has to become the mandatory constraint, the foundational context that is rigorously, intentionally built into our AI models. Think about it this way. Neuroscientists tell us that the algorithms of the human brain are largely contextualized by our environment, right? By our families and society, mostly during the first 7 years of our lives. We are essentially these brain-inspired learning machines. So if we want AI to be safe, we have to intentionally do the exact same thing. We have to explicitly build an empathetic framework around it, much like raising a child with strong, clear boundaries. So, who is actually responsible for building this context? Well, spoiler alert, it's not just software engineers in a lab. It requires all the pillars of our society coming together. We're talking about religions transmitting universal respect, schools evolving to teach empathy as a real, measurable skill, families providing that crucial initial context, neuroscientists modeling the feedback loops, and enlightened entrepreneurs anticipating what society actually needs. Basically, it takes a whole ecosystem to raise a safe AI. All of which leaves us with a pretty vital question to ponder. Will we ride Transition 5.0, taking the reins, planning meticulously, and actually coding empathy into our future? Or are we going to act like those new graduates back in the 1990s, just passively improvising, hoping the machine figures it out on its own, and ultimately suffering the disastrous consequences? That choice is entirely up to us, the human drivers. Thank you so much for joining me for this explainer. Keep learning, keep planning, and I'll catch you next time.